Hello all, let's start section 2.7. 2.7 is inverse functions. Even before starting inverse functions, I change a little bit the order of topics in this section. First, I want to talk about one-to-one functions. Somehow in this section they are talking about this topic at the end, but I want to talk it at the beginning of this lecture, totally opposite the way that your book wants to go. Because if you don't know what is one-to-one function, talking about inverse functions are yeah, we can talk, but we don't know it by heart, right? Let's first learn what is one-to-one function. One-to-one functions are the functions that for every element in the domain X, for example, every element, at the same time that I'm talking, I'm also drawing for you, there is only and only one element in the range. You may say like, yeah, it was the same definition for the functions, but I'll explain something else here also for you. Let me change the range to Y. For every element in the domain, you have only one element in the range. For every element in the domain, you have one in the range. Every element in the domain, you have one element in the range. The opposite way should also work. For every element in the range, there should be only and only one corresponding in the domain. You see, I draw like this. Both sides. We call this one-to-one. Look, before you could have this. You could have this. 1, 2, 3. Correct? 1 goes to 3, okay. 2 goes to 3, okay, yes, it's a function. But this one is not one-to-one because you see, 3 goes to 1 and also 3 goes to 2. This is not one-to-one, only 1, 2, 1. It's only represents a function, but this one represents a one-to-one function. Correct? Now, one-to-one functions are the functions that if you look to their graph, by drawing a horizontal line test, you can identify if they are one-to-one or if they are not one-to-one. Look at this graph. If they give you few graphs like this, for example, this graph, or they give you this, or they give you this graph, which one of these graphs are one-to-one? To find which of these graphs are a one-to-one, representing a one-to-one function, we do a horizontal line test, correct? For finding or knowing if a graph represents a function, you did before a vertical line test. Now what we do a horizontal line test. Draw a horizontal line on your graph. If your line only intersects the graph in one point, it's one-to-one. Look, on any point, if you draw your horizontal line test will only hit the graph once or intersect the graph once. We call this graph is one-to-one, correct? But look at here, if I draw my horizontal horizontal line, my line intersects the graph twice, then I will say not one-to-one. Correct? This is one of the tests that you can do to find a one-to-one function. Now, when you learn what is one-to-one function, now I can talk about inverse of a function or inverse functions, correct? Inverse functions. When you can call a function or two functions inverse to each other. In your book, they put a definition in this way. I will do the same thing, but I'll explain it in a different language also for you. If you have two functions, one of them is f and one of them is what? G. You can call these two functions or one-to-one to each inverse to each other if f of g of x becomes only x, or g of f of x gives you only x. This is actually also the definition and also the test to find if two functions are inverse to each other. Correct? The symbol for inverse functions is this. You write f or g, whatever the name of your function is, and in the top you put -1. Please do not read this one as a f to the power of -1. No, the meaning of this is inverse. Inverse f. You read it this way. Inverse f of x, or inverse function of f. Correct? Now, let me explain this definition in a different language also for you. If I have a function, for example, f, let me draw here a table for it. X, y. For example, even I don't have a function, you see, I just named f, but later we will do examples. For example, 1, 2, 3, here -4, -8, -10. And I have a function g. And here x, here y, and I have like this, -4, -8, -10, 1, 2, 3. I call these types of functions one-to-one. What does it mean? Look, for the function f, x's domain, y is range, right? What do you see on g? Actually, the domain of g is the range of f, and the range of g is the same as domain of f. That's the relation. We call these types of functions one-to-one. When the domain of one function, in easy language, when the domain of one function becomes the range of the other function, and the range becomes the domain, we call these two functions one-to-one functions. Correct? Now, before finding one-to-one functions or finding the inverse of a function, let's practice. Let's check how you can kind of identify F2 functions or inverse to each other. Correct? Let's do an example, or let's put a topic. Verifying inverse functions. How to verify F2 function is inverse to each other. Two given function is inverse to each other. Do this test. Find f of g of x. If your answer becomes x, they are inverse. If it's something else, they are not inverse. Or find g of f of x. If your answer becomes x, they are inverse. If they don't become x, it's something else, x plus 2, x minus 3, or something else, they are not inverse. Correct? Let's do example. This is the test. This is the test that you are required to do. And what is this? It's actually the composition of functions, right? In my previous lecture, I explained to you how to find the composition of two functions or composite functions. Actually, you do that here, correct? Example number 1. F of x equals 3x plus 2 and g of x equals x minus 2 over 3. We are checking if these two functions are one-to-one to each other. Sorry, not one-to-one, inverse to each other. Correct? To do that, pick one of these tests. Which one you want to do. Pick this one, the first one, find f of g of x, or find g of f of x. Which one you like. Doesn't matter which one you choose. I'll choose this one. I'll try to find f of g of x. F of g of x equals, plug in g and f, remember? Plug in g where? And f. Then f of g of x equals 3 times x minus 2 over 3 plus what? 2. Let's simplify. It's equal, 3 cancels out with 3, x minus 2 plus 2. 2 cancels out with 2. What is your answer? Your answer is x. And what was the condition? F of g of x, the answer becomes x, your functions are inverse to each other. And you see your answer, your composition become x. Then you can call f of x equal 3x plus 2 is the inverse of g of x equals x minus 2 over 3. Or the other way, g of x equal x minus 2 over 3 is the inverse of f of x equal 3x plus 2. Correct? This is how you find or you verify if two given functions are inverse to each other. Next, let's do one more maybe. Let's do one more, then I'll jump to another problem. F of x, let's do one example more. I don't want to do only one example for you. Let's do one more. Example number 2. F of x equals 7x minus 5 and g of x equals x plus 5 over 7. Verify if these two functions are inverse to each other. Correct? What I do, I'll find f of g of x or g of f of x, which one I like, correct? F of g of x means plug in g in what? In the variable of x. Then I can write 7 times x plus 5 over 7 minus 5. 7 cancels out with 7, x plus 5 minus 5. 5 cancels out, equals x. Then my answer is yes, they are inverse to each other. Very easy, correct? Now let's discuss another topic. Finding the inverse of a function. Finding the inverse of a function. To find the inverse of any given function, but remember, you can only find the inverse of a function if your function is one-to-one. If your function is not a one-to-one function, then you cannot find the inverse, correct? Only one-to-one functions, they have inverse, which is not mentioned clearly in this topic. That's why I discussed that one-to-one function at the beginning. Correct? Remember always, only one-to-one functions, they have inverse. Correct? Now, to find the inverse of a function, just follow this 4 steps. Step 1. If the function is given in the form of f of x, replace f of x with y. That's your step 1. Correct? Step 2. Interchange x and y. Interchange x and y. Step 3. Solve the equation for y. Last step, step 4. Change, or I can say replace, y with this symbol, f inverse of x. That's it. you are done. You can change, you can find the inverse of any one-to-one function which is given to you if just simply follow this 4 step. I'll try to do an example in front of this on the right side, and I'll show you 4 steps there, right? For example, f of x equals to x plus 1. They're asking you find f inverse of this function, f inverse of x. Step 1, I'll just follow the steps. Replace f of x with y. Then I will write y equals to x plus 1. Step 2, interchange x and y. It means x comes here, put the y here, correct? And write this way. X, or let me use the same colors to can explain it more better for you. X equals 2, y comes here. Y plus 1. Do you see how I did? Interchange x with y. Step 3. Solve this resulting equation for y. To solve this equation for y, I have to first subtract 1 from both sides, right? Because I'm solving it for y. Then I can write x minus 1 equals, these two cancels out, 2y. Now divide by 2. I can write y equals x minus 1 over 2. Step 4, last step. Change y to what? To f inverse x and keep the right side. X minus 1 over 2. Here you go. This function is the inverse of 2x plus 1. One more. Let me do one more example for you. F of x equals x plus 2 over x minus 3. Step 1, y equals x plus 2 over what? X minus 3. Change f of x to y. Step 2, interchange x with y. Correct? It means you can write x equals y plus 2 over y minus 3. Step 3, you have to solve this equation for y. To solve this equation for y, we already explained, I want to remove my denominator, then I have to multiply both sides by y minus 3, correct? These two cancels out, correct? Here, distribute the x to here, xy minus 3x equals what left on this side? Y plus 2. Correct? Now, the terms that they have y in it, one side, the terms that they don't have y in it, on the other side. It means I will subtract y from both sides and I'll add 3x to both sides. Correct? Y cancels out with y, 3x cancels out with 3. Here I will get xy minus y equals 2 or 3x plus 2. Correct? Now, next step, I'll take y as a common. Y, x minus 1 equals 3x plus 2. To solve for y, I have to divide both sides by x minus 1. These two cancels out. Then y equals 3x plus 2 over x minus 1. Last step, f inverse x equals 3x plus 2 over x minus 1. Final answer. Correct? Last topic in this section that I want to discuss with you is how to graph a function and also its inverse. Correct? I'll show you if I do even only one example for you, that will be enough, but I'll try to do 3 examples for you. Graphing a function and its inverse is really easy. If you focus on my lecture, at the beginning of this lecture, I explained something to you. If you follow that, you can graph any function. But anyway, I'll explain it here again. I will explain this topic. Let's put first a topic. Graph of f and f inverse. In some books, they give you kind of definition. The graph of f and its inverse is actually the reflection of f around line equal xy, which is a diagonal line, correct? It's kind of reflection. But how to graph in an easy way? Let me explain it in an example. Example number 1. For example, which one? Let's pick an example from your book. Let's do this. Y equal square root of x. Very simple one. Y equal square root of x. Correct? To graph this, I know the shape already. Correct? Because I gave you 7 graphs the other day that you should know the name and the shape. Few points. You know the domain of this function is from 0 to infinity. Correct? Because it's a square root function. Then plug in few numbers, correct? When x is 0, if you plug in here 0, y becomes 0. When x is 1, y is 1. When x is 4, the square root of 4 is what? 2. Let me graph first this function. 0, 0, 1, 1, and 2, 3, 4, and 2. Let's say this point, 4 and 2. If I graph, that was the shape of your one-to-one square root function, correct? Now, I want to graph the inverse of this. Please, please do not try to first find the inverse of this function. No, you don't need to. Remember what I told you, that the domain of the inverse is the range of the function, and the range of the function is the domain of the inverse. It means I'll do this. Look, my y column will become the x for the inverse, and the x column becomes the y for the inverse, correct? Now, what I do, I'll just graph this. X0, Y0, same thing. X1, Y1, X1 and Y1, this point, the same. X2, Y4, X2, Y4, 2, 3, 4. X2, Y4 is here. And if I graph, I will end up with this shape. Now, if you graph y equal x, which is always this line, right? Everyone knows what is y equal x. It's always this diagonal line, 45-degree. You see, this function was f of x, and this is the inverse f of x. They are the reflection of each other. Very easy way. Every time that you want to graph the inverse of a function, just do this, because the range is the domain, domain is the range. Just flip your table and graph the inverse. Correct? I'll stop the lecture here. This was all about section 2.7. I'll stop the lecture and see you next time in section 2.8.